Let's do the ready, set, go on lesson 2. Be quiet, be discreet. In the ready section, we're working on the slope. So it asks us to find the slope of these two triangles, or from these two triangles. The rise is 8, the run is 4. The change of the y is 8, the change of the run, or the x, is 4. 8 divided by 4 is the slope is 2. On the other one, the rise is 2, the run is 1, the slope is 2 divided by 1, or 2. Is the slope the same in each? Yes. Why? Because the size of the triangle doesn't matter. It's the ratio. Size doesn't matter. It's the ratio. Now, in a table, when we did this in Unit 1, we usually just looked at the change in the f of x. And this is changing by 8 here, from negative 19 to negative 11. But then it changes 16, and then it changes by 12. What's going on here? Well, on the other side, you have to look at the change of the x as well. This is changing 2 from 3 to 5. This is changing 4 from 5 to 9. This is changing 3. And, if you take 8 divided by 2, if you take 16 divided by 4, if you take 12 divided by 3, you get the same number every time. You get 4. So what's going on? You have to look at 2 points at a time. See, nobody said things have to be equally spaced out. On this other example, things are evenly spaced out. You've got from negative 27 to negative 23 is a distance of 4. This is 4 again, this is 4 again. But look at what's happening over here on the x. It's changing by 1, it's changing by 1, it's changing by 1. The reason that they're all 4s out here is because they're all 1s over here. If you change how far you're looking on x, of course that's going to change how far you're going to look on y. That's why the ratio is so important. You have to have a change of y divided by a change of x. So this is also 4. Yes, the change of y divided by the change of x is 4. Let's go on to the next part. Here's something you might have done in junior high, you may have forgotten it. When we have an equation that's solved for y, something special happens with the slope. In fact, this number 3 is almost solved for y. See, these negative 6 and positive 6 would cancel. We could divide by negative 2 on everything, and we would get y is 3x minus 1. Well, when you have an equation solved for y, the number in front of x is the slope. 3 is the slope. And on the other example, 3 is the slope. On both of these, 3. If y equals something, then the number in front of x, we call that number the coefficient. The number in front of x, 3 is the slope. Let's take a look at 4. 4 is rising by a half. If you'd like, we can write that as a decimal, 0.5. Its change of x is 1. 0.5 divided by 1 is 0.5, or you could just say half. On the next one, the rise is 1, the run is 2, the slope is 1 divided by 2. The slope's the same. What does that show you? It's not the size of the triangle, it's the ratio. The ratio, the fraction, determines the slope. The ratio determines the slope. Okay, on these next few problems, all we're going to do is we're going to look at what kind of a situation is it, what might the graph look like, and is it discrete or continuous? Okay, so freeway construction crew pours 300 feet of concrete in a day. Likely that graph is going to look like this. It's going to be continuous. They have these machines that will lay out freeways. They just work at the same rate at all the time. And that makes it continuous. Is it linear or exponential? I spelled that wrong. Continuous. Yeah. It is linear. It's going at the same rate all the time. Number 6. For every hour that passes, the amount of area infected by the bacteria doubles. Doubling, does that sound like exponential? So this graph, it's going to be connected. It's going to go like this. It's connected because it makes sense to talk about in between the hours. So therefore, it's going to be exponential, and it's also going to be continuous. 7, to meet the demands placed on them, the bricklayers have started laying 5% more bricks each day. When we've worked with this before, we know it's geometric because we have a multiplier 1.05. Okay, so let's try to think about that. What would that look like as they keep laying bricks? Each day they get 5%. So would it make sense to talk about in between the days? I don't think it would make sense to talk about in between the days. So on this one, we're going to use dots. It would probably look something like this. It's curving, but it's not connected. So it's exponential, but it's discrete. Number 8, the average person takes 10,000 steps in a day. So does it make sense to talk about in between the days? Not really. No, it's 10,000 steps this day, 10,000 steps the next day. Adding those together, it would be something like this, a series of increasing dots. Therefore, it is discrete and linear. The city of Buenos Aires has been adding 8% to its population every year. That one would also look the same way as you're seeing the data come in year by year. Discrete and exponential. At the headwaters of the Mississippi River, water flows at a surface rate of 1.2 miles per hour. When you got water and it's flowing, then you're going to look at a solid or continuous state. This one would be likely linear. I'm going to skip ahead to the go section, so we won't be doing these problems here. We start off with 2 examples. The first example is a one-step equation using addition. Subtraction is the way to go here. We're trying to make a 0. And to do that, we're starting with plus 7. So the part that gets put in by you, the student, would be this minus 7 right there in blue. And you do that to both sides of the equation to keep it balanced. Now in the other example, where we have 9x, we're trying to make the number 1. 9 over 9 is 1. We'd like 1x when we're done. So multiplying a number times its reciprocal will always give you 1, except for one number, the number 0. So a over b, a fraction, times b over a, the reciprocal, is equal to 1. And this works for any case except where a is equal to 0. So that's what they did. They took the 9 and they turned it upside down. Okay, let's solve these equations. We have x with 16 being added. We want to make 0 by subtracting 16. That zeroes it out. So x is 36 minus 16. On number 15, we have 425 times x. We're going to divide. 425 divided by 425 is 1, so we have 1x equals, and that goes in there 2 times. 1/6 times x is the same as dividing by 6, so we'll multiply by 6, or if you think about reciprocal, we'll multiply by 6 over 1 on both sides of the equal sign. In fact, some people like to draw a line through the equal sign just to remind them that what they do to one side of the line, they do to the other side of the line. So x equals 60. Next, we're going to use the reciprocal. So we're going to take the fraction -4/7 and flip it upside down and make it -7 over 4 on both sides of the equal sign. X equals, and a negative times a negative is positive, and it's 7 over 4. No need to put it as a decimal. Lastly, we're going to review finding recursive and explicit equations. On number 18, we're going down by 4 every time. That's the common difference. So recursively, we'd say we start f of 1 at 20. And to get the next term, you take the previous term and subtract 4. Explicitly, that would be f of n is starting at 20, subtracting 4, and we are starting at the term value of 1, so we'll put n minus 1. Number 19, we're multiplying by 2 as we go down. That's our common ratio. R equals 2. Explicitly, that would be f of n is starting at 9, multiplying by 2 to the n minus 1. Again, we're starting at 1. Recursively, we start at 1. And the first term is 9. And to the previous, we're going to multiply by 2. We could put the 2 at the end, we could put the 2 at the beginning. Now, a little variation here on number 20. Now we're starting at 6. Explicitly, we would still start with f of n. You still start with your first number 20. But now, okay, and by the way, on this one, we're multiplying by 3. We're going to multiply by 3, but to compensate for the fact that we're starting at 6, we're going to subtract 6. Recursively, we would say now f of 6 is 20, and f of n equals the previous times 3. So a few little changes there when we start at 6. 21. F of n, let's do explicit. Start at 10, and you're actually adding 10. So it's going to be arithmetic, and we're starting at 4. So to compensate for that, we do n minus 4. There's our explicit. And then f of 1, no, f of 4 equals 10. And f of n equals the previous plus 10. I hope that review helped. We'll see you next time.